Today we are moving on with triangles, more so looking at right triangles, okay? So for right triangles, we are going to use the Pythagorean theorem if we have a missing side. Raise your hand if you have heard of the Pythagorean theorem or used the Pythagorean theorem before.
A squared plus
Awesome.
B squared equals C squared.
Yes, I put him up there for you. Pythagorean theorem is up there.
Oh.
Hardest thing, let's look at this triangle right here. I think the most difficult thing is setting it up correctly. Once you have it set up, normally you're okay. Okay? So, it says a squared plus b squared equals c squared. I labeled it for you. Leg plus leg equals hypotenuse. Or short side plus short side equals long side. Or the two angles that touch the right angle equal the side across from the right angle. Okay? So, what I advise is when you're doing this, circle your legs. So 5 would be a leg because it's connected to that right angle. And 12 is a leg because it's also connected to that right angle. Okay? C is across from the right angle, so that is your hypotenuse. The hypotenuse, or the side across from the right angle, is on its own side of the equal sign. Okay, so to set this up, I would do 5 squared plus 12 squared, leg plus leg, equals c squared, or hypotenuse squared. Okay, write this down. The next thing that a lot of people forget is to make sure that you square all of these. Very important, make sure all of these are squared. Okay? So now we just solve. What's 5 squared?
25.
What does squared mean?
Times itself.
Times itself. So 5 times 5 is 25. What's 12 squared? 144, 12 times 12. And then c squared we keep because we're solving for c. Okay, what's my next step here to solve for c? Combine like terms. What's 25 plus 144? 169 equals c squared. Okay, another tricky part. How do I solve for c from here?
You square root it.
Take the square root. To get rid of a square, we take the square root of a number. Okay, so here, yep, square root of 169 is 13. Let's look at this one. Okay, let's label first. Someone give me one leg. Tell me what one of the legs are.
B.
7 and B. Why are those the legs? Bless you. 2 connected to the right angle. Okay, and they're the smaller sides. Okay, so how do we set this up then? 7 squared plus b squared equals 14 squared. Do not forget the squareds. Okay, and it's leg plus leg equal to the other side, the hypotenuse, on the cross from the right angle. What's 7 squared? 49. B squared stays as b squared. What's 14 squared? 196. Okay, now it's just an algebra problem we're solving. How do I solve for this here? Minus 49. What's 196 minus 49? 147. What's my last step to get b by itself? Square root. Take the square root. What is the square root of 147?
12.1.
Right. So if you get a decimal or a fraction, depending on what kind of calculator you have, we are just going to keep it as a square root. Okay? Just keep your answer as a square root. If it's a decimal, keep it as a square root. Let's try do number 1. Just do number 1. All right, on number 1, which ones are my legs? Give me one. 6. The other one is A. Good. So how do I set it up? A squared plus 6 squared equals 10 squared. Okay, leg plus leg equals hypotenuse. Okay, so A squared stays. What's 6 squared? 36. What's 10 squared? 100. What's my next step?
Subtract 36 from 100.
Subtract 36. What's 100 minus 36?
64.
Okay, what's my next step?
Square root it.
Get A by itself by taking the square root, so we get A equals
8.
Okay, we're not going to go through 2 and 3, but let's set them up at least. Okay, on 2, what are one of my legs on 2?
17.
What's one of my legs? 15 is one of my legs connected to that right angle. What's the other one?
B.
And B, because it's connected to my right angle. Why is 17 our hypotenuse, our long side?
It's not connected to the right angle.
Not connected, it's across, and that's our longest side. Okay? Let's set up number 3. What are my 2 legs?
Do you know the answer to that?
I can tell you in a second. What are my 2 legs?
15 squared.
On number 3, sorry, we're on number 3. 7 and 8. So we have 7 squared plus 64. 8 squared, but it is 64. Equals c squared, and then you would solve from there. Okay? Moving on here to distance formula. We are talking about points on a graph now. Okay? What do we see in this graph here? We have 3 different points. What do they make?
Triangle.
What kind of triangle?
Right triangle.
They make a right triangle. So with a right triangle, what can we use to solve for sides? Pythagorean theorem, okay? However, do we know any of the sides?
No.
No, but can you find them?
Yes.
How?
Just count.
Just count. What's the distance from A to C? 3. What's the distance from C to B? 4. What about A to B?
Don't know.
We can guesstimate, but if it's diagonal, can we really know what it is?
Yeah.
So I'm going to put a C there. How do I solve? What do I use?
Pythagorean theorem.
Pythagorean theorem. What are my 2 legs? 3 and 4. So we have 3 squared plus 4 squared equals c squared. Okay, in your homework, it's going to have x there, but it's the same thing, okay? So what's 3 squared? 3 squared's 9. What's 4 squared? 16. What's 9 plus 16? 25. Last step. Square root. So we get c equals 5. So our hypotenuse or our long side is 5. Okay? So you can use the distance formula, you can find distance using the Pythagorean theorem. Okay? Now we're going to look at the actual Pythagorean theorem. Okay? So I put it up there for you. Let's start by labeling first, because once we label, then we can just plug it into the formula. Okay? So now we don't have a right triangle. Okay? You can make one, but we're going to use the distance formula. Okay, so what I'm going to do is I'm going to label these coordinates. Coordinates are labeled as x and y. So I'm going to label D as x1, y1. What am I going to label E?
X2, Y2.
X2, y2. So now I'm going to follow that formula that I put up on the board for you. Okay, so distance equals the square root. What's my x2? 3. What's my x1? So subtract. And then in parentheses, squared, plus, now we do the same thing with the y's. What's my y2? -2, y1, and then squared. Make sure if you put x2 first, you have to put y2 first. If you put x1 first, you have to put y1 first. They just have to match. Okay? So now we just solve. Order of operations, what does it tell you to do first? Parentheses. What's 3 minus 1? 2. What's -2 minus 2? -4. Since it's negative, I'm going to go ahead and put it in parentheses. Okay. What is my next step in order of operations? Exponents. What's 2 squared? 4. What's -4 squared? 16. So if it's negative, your answer is going to end up positive. Why is that? Negative times a negative gives you a positive. Okay. Last step. 4 plus 16. 20. Is there such thing as square root of 20?
Yeah.
No.
No. So what do we do with our answer? Just leave it. Yep, keep it. So it's all just step by step of the order of operations. Okay. Go ahead and try number 5. Start by labeling x1, y1, x2, y2, and then plug it into the distance formula. And then we'll do it together. Just do number 5. So let's start by labeling. I'm going to put D as x1, y1. I'm going to put E as x2, y2. Now go from there. Plug them into the formula. So now that I have them labeled, I'm just going to go ahead and plug them into the formula. Okay? What is my x2? What's my x2?
Oh.
3. What's my x1?
Oh, I did that completely wrong, Michigan.
Squared. Plus, what's my y2? What's my y2? I know some of you are working. What's my y2? Negative 2. What's my y1? Squared. Okay, what's my first step in order of operations? Parentheses. What's 3 minus 1? 2. What's negative 2 minus 4? Negative 6. What's my next step?
4 plus
Exponents. 4 plus 36. What is 4 plus 36? 40. Is there such thing as the square root of 40?
No.
No. So we leave our answer like that.